Hello, my name's Niall. I'm from RtTech Software. I'm with Rob Brannan. He's over from the UK. He's my counterpart. Today we're just going to be going over how to reduce downtime, increase overall equipment effectiveness, So RtTech was formed in 2011, and even though it was formed in 2011, the product's been developed since 2002. At RtTech, we only produce two applications, RtDuet, which will be the main focus of our conversation here today, and RtEMIS. RtDuet is our downtime monitoring system, and RtEMIS is an energy management system. We can speak about that later on. However, today we're just going to be speaking about RtDuet. So our main focus is developing industrial apps for operational intelligence in industrial facilities. Obviously, the two apps are RtEMIS and RtDuet. RtDuet optimizes asset utilization, reduces downtime slowdowns, and it obviously increases worker productivity. And if you look at RtDuet, it stands for real-time, downtime, uptime, event tracking. Obviously, RtDuet reduces energy costs. At the moment, we are monitoring over 2,500 machines across the globe, over 75 sites, over 21 countries. And as you can see here, the buckets here, RtDuet is the first bucket, RtEMIS is the second bucket there. You can see there's some quite large companies that we work with across the globe, pharmaceutical, mining, manufacturing. And we also have established partnerships across the world as well. Microsoft, Mesa, OPC, numerous ones as well. So basically today's talk is a general overview, introduction to OEE, best practices in running an OEE project, keys to success including asset hierarchies, reason trees, and time usage models. How to improve OEE including real-time applications, and we'll finish off with some questions. So feel free to ask this question at the very end. And at this moment, I'm just going to introduce Rob Brannan from the UK, and he's going to talk about OEE.
Hi everybody, hope you can hear me okay. I'm conscious that I've got a little bit of an accent, so I will speak as slowly as possible, but if I get a bit too quick, just give me a shout. So as Niall says, and as he's covered off, we're obviously a company born out of Atlantic Canada, but we've got a worldwide presence now, stretching right across to Australia, Europe, Middle East, and obviously North America as well. Just wanted to start off by introducing people to OEE. I'm not too sure how many people in the room know what OEE is or what it's used for. And I'm just going to cover that off now and just break it down into the three different buckets that consist of that calculation. So OEE has been around now for a long time, 1950s, 1960s. Started off in the automotive industry, but it has been adapted to any industry now. Essentially, if you're looking to improve the effectiveness of your assets, be it a standalone machine or a production line process, then OEE is a calculation that you can use. Essentially, it's broken down into what they call the 6 major losses. So on the left-hand side, under the availability element of OEE, we have things like breakdowns. So typically they're things like tooling failures, unplanned maintenance, general equipment breakdowns that may occur as your process is taking place. Also as well, an area that is quite an interesting one is kind of the setup side of things. So things like changeover times, things like material shortages, operator shortages. In my experience over the years of deploying OEE applications, the kind of setup side of thing and the actual process elements sometimes outweigh the actual mechanical aspects of the machinery breaking down. So typically the machinery is very, very reliable, but what people tend to find is once they start measuring OEE and monitoring their processes, that a lot of their stoppages can be down to things like waiting for parts, waiting for operators. And we can talk about how we cover that off and how we can help with that, but yeah, it's quite eye-opening for a lot of companies. They just seem OEE as it's machine, it's either started or it's stopped. Yeah, that is generally the case in terms of the availability side of things, but you need to look at the whole process within your organisation, and I think you'll be quite interested to see some of the elements that come out of that once you start measuring it. The performance element, that's more looking at things like nameplate capacity of your process. So You know, I have a machine, I have an asset, I have a line, you know, it should be producing X amount of units per minute. Is it? If it isn't, why isn't it? Typically when people are doing OEE to begin with, say in a manual mode, a lot of the performance losses will be hidden because they're so small and so quick. So you may get a slowdown event only occur maybe just for a minute or two. You start adding them up over each machine that you've got in your facility or across your corporation, that becomes quite a big loss for you. So unless you're measuring that real time, they're kind of hidden to begin with. But we'll talk about again how we can visualize those and bring them to people's attention as we move on. And then the final component is quality. So that's looking at total amount of items produced against how many have been rejected, and what the reasons why for that as well. So that's the kind of breakdown of OEE. Typical kind of OEE benchmarks that exist, obviously 100%. I've never seen it occur yet, so you never know, it may happen. Typically what we tend to find is if we move right across to the right hand side first of all to begin with, 40% is typically a common figure that we see when we first start engaging companies. If I'm honest, if companies are doing OEE manually to begin with, they tend to be producing a higher figure, maybe up towards the 80–85% mark. And the reason for that really is the granularity of information that they're capturing. If people are capturing downtime information, performance information manually on bits of paper or spreadsheets, then realistically they're only going to be able to capture, say, 10-minute buckets at a time. So those kind of tiny stoppages that are occurring, operators won't be collecting that information. It's just, you know, using spreadsheets and bits of paper to capture information is just not viable for them. So there's a lot of hidden losses, hence why the OEE figure tends to be a little bit higher, because people tend to round things up. So maybe I had a stoppage on my process on my line, I'm busy trying to get it fixed and get it back up and running. I put it down as 15 minutes, when maybe it only been 8 or 7 or 6. You add them up over the course of a shift, a week, they're quite sizable numbers that are getting missed off. So the target range really typically is between 60 to 85. It's just a figure at the end of the day. You know, the information is really when you start drilling down on it. You know, people shouldn't get hung up on, I need to be 85% world class. It all really depends on your process, your people, the parts you're producing, how things are set up, change over time. There's a lot to consider, and we'll talk about that in a moment. So how do you calculate OEE? It's a simple mathematical calculation. I'm not going to run through it all there in too much detail, but essentially you're multiplying your availability, your performance and your quality, and that gives you your OEE figure. So you can just, if you can just see there, it's a little bit small, sorry about that, but availability is looking at your running time divided by your planned production time, and then obviously your performance rate is total pieces, your running time, your idle run rate, and that's going to vary. And that's the great thing about OEE. Once you start driving into it, it begins to highlight maybe problem running products. So I've seen it a lot in processes where you've got a production line where you may run product A on line 1 and you're getting a really good run rate. You switch to product B, you're going to be getting a lesser run rate. Maybe the component you're putting down that line is bigger, it's heavier. Maybe the quality rate's being affected. So these are all things to consider, and it's only really when you start capturing that information real time that these things start coming to life. So as I said before, most people will start measuring OEE or capturing downtime manually to begin with. It's a great starting point. It can become challenging. I think most of the companies that we speak to, when they start looking at our solutions such as RT Duet, no one would ever come to us of not doing OEE manually. They would have done it first manually, maybe outgrowing it, maybe want to take the next step, and that's when I look to kind of measure things real time as well. So obviously capturing things manually can be difficult, as we talked about before. I've worked in organisations where each machine has had a separate bit of paper, there's no standardisation, people are describing downtime events how they wish. It can be, like I said, pretty much impossible to capture the performance losses that are occurring in the process as well. And that data tends to be quite siloed and tucked away and very difficult for people to get hold of. So that's kind of the OEE figure broken down in its simplest chunks. So you start off really with your planned production time. That's typically your shift. If you're doing shift-based OEE, if you run an 8-hour shift, that's what you start off with at the top. So you've got your planned production time. You take away your scheduled stops, maybe some planned maintenance that you've got scheduled for that piece of equipment during that shift, or breaks. That leaves you your running time, and then obviously you've got your breakdowns and your availability losses coming away from that. And essentially you're working down different chunks of time where you're incurring losses. So effectively you may start off with 8 hours available where you can make good parts at the 100% run rate that you could achieve, but realistically as you move down, losses are occurring as they go, and all we're simply doing with the OEE calculation and RT duet is attributing those losses to separate little buckets to allow you to understand, I started off at 8 hours, at the end of the shift we only really produced good parts for 6 of those hours. What happened to that other 2 hours? You know, why? And measuring OEE and using a tool like RT duet will help you understand that. So people measure OEE different ways. It really depends on your process and your and how busy you are. Some operations are 24/7, some aren't. People typically will do it on a shift by shift basis. So like I said before, depending on your shift patterns, it could be an 8-hour shift that you run or a 10-hour shift or 12-hour. People can as well break it down to individual product runs. It really, again, depends on your process. So what that allows you to do then is actually say, okay, I can have a shift summary. So my OEE for the shift was, say, 70%. But what's made up of that 70% figure? You know, maybe you've done 3 product runs, 2 product runs are great, 1 wasn't so great. So that allows you to analyse that individual product run, which is bringing your OEE score down, and allow you to understand, you know, how you can hopefully correct that in the future. So for me, if people are looking to move from a more manual-based OEE system to a real-time system such as RT duet, typically these are the kind of best practices that we would encourage people to deploy and utilise to make their project as successful as possible. So first of all will be to ditch your spreadsheets. I know people still love Excel, and it is a fantastic tool. We actually export our data into Excel because obviously there's still some great reports that people want to run themselves, but as a data collection tool, it's certainly not the best. So we'd urge it initially, and then pick the right tool for the job. You know, the companies we work with have numbers of systems in place, be it ERP systems, MES systems, maintenance packages, scheduling systems. The tendency can be sometimes to, I don't know, maybe take one of those existing applications that you've got and put an OEE bolt on the end, or a downtime module that they may have. There's lots and lots of great downtime and OEE systems that exist that are standalone, that do a fantastic job. So for me, you know, from my experiences, would be to pick one of those solutions. It doesn't have to be ours. It can be if you want it to be, but pick the right tool for the job. You know, make sure it's going to do exactly what you want it to do. Make sure it's customizable to your process and it fits your requirements. Next step would be to start small. The tendency is for a lot of companies wanting to kind of deploy a system like ours is to say, okay, I want it across every asset across my corporation, which, you know, for my boss sounds great, but realistically, we was always kind of bring people back a little bit and say, look, let's just take this one step at a time. Maybe pick some low-hanging fruit. Maybe pick a process where you know where you think you're getting quite a lot of issues. Start a pilot. Maybe do 2 or 3 machines on a production line, and start it small from there. It allows you to focus your attention on that process. Allows you to really understand the information that you're getting from the system. Allows you to make changes as well, because realistically, when you start deploying a tool like RT duet or any downtime system, the very, very first phase, you know, you fast forward to 6 months down the line, it's going to be very, very different on how you've calculated it, how you've set it up, and, you know, how you've tweaked it to give you the benefit that you want, and then you can roll it out from there. Be clear on what you want to measure. As I showed you before, OEE's got 3 distinct areas to it: availability, performance and quality. Again, through my experiences, typically people will start with availability or performance, or them two to begin with, because they're the big hitters. That's where the biggest opportunity is to get a return in investment on your outlay. And then they maybe do quality at a later point. But it's up to you. But all I would say is, yeah, definitely be clear on what you want to measure. I'm just checking the time here. We're doing good? Yeah, that's fine. Be clear on what you want to measure. Articulate that around the organisation. You know, when you're speaking to IT or operational people, or you know, the operators who are going to be involved in this project, is yeah, be clear on what you want to get from the system and tailor it from there. Definitely make it a team effort. I can't emphasise this enough. The best projects I've been involved in have involved operators from the very, very start. You know, they've allowed them to put their input into what they want the system to do, because they're the people that are going to be giving you the information. So definitely involve them from the off. Get a system champion from the operational side of the business and the IT side of the business as well. Make sure they work together as best they can. I know it can be challenging at times, but like I said, the best projects I've been involved in and most successful have been when IT and the operational teams have worked close to ensure that they've picked an application that suits both parties. Share the data. That sounds a bit of a crazy one, but if you're running RtDuet on 3 machines on a production line at one of your sites, share it out there. Make people aware of the information that's available to them. The data that can be gathered here and utilised can be used by many, many different people within the company. Operators are going to get benefit from it, plant managers, operational managers. You can share information to maintenance teams, continuous improvement teams. Utilise the information you've got. Make sure as many people are getting visibility of the information you're capturing, and that's when you get more and more benefit from a system like ours. And then for me, it's collecting the data, but definitely real time. I can't emphasise that enough. If you're out at the early stages of deploying OEE, yeah, definitely do it manually to begin with, but don't hold on to their spreadsheets too long. They'll get too overgrown and very, very hard to manage. So take the plunge and move to a real-time system as soon as you can. So how is the best way to use software to calculate OEE and what the benefits it brings? So just that little diagram there on the right-hand side. And the great thing about today's age really is that most information that you require is going to exist already. It's going to be in your machines. And it's pretty simple this day and age now to extract that data as well, using things like OPC or interfacing to devices that are collecting information or plant historians that you may have. That information will then go into the software package of choice, in this case here, the RtDuet. It'll be saved in a database, that's another plus point straight away. So all the information you're capturing and storing is there and it's accessible, and you can, as I mentioned before, if you want to drag the information out and share it with other tools, you can. And then at the very, very top level, the next level up, we've got our configuration toolkit, and that's where we really offer, for me, a great service, because it's not just about getting that real-time data in, it's about doing it in a way that's allowing you to get benefit from it in an easy-to-use format. So things like configuring timeline definitions, so as I said before, understanding each process individually, your shift patterns, your production schedules, things like standard reason tree codes. They're really, really vital, ensuring that you get good data from the system. So I'll talk about that in a little bit more in a moment. And then increased visibility with real-time dashboarding. Again, I can emphasise that massively. Bring that data to life, get it on big screens, above production lines or on assets. Share it out. Make sure that you pick a tool where, if I'm a plant manager, I can have visualization of maybe a larger area that I want to look at. Then the operators make sure that they've got visual aids that are close to them, so they can see real time exactly how they're performing, what losses are occurring during the shift there and then. And that's what a tool like this will give you. So there's a little bit about the asset hierarchy. So essentially it's just giving an example there of how we build the logic within our application. So you can start off at a division level, and then the next step down will be a site, then an area, and then what we call machine centers, which are basically individual assets. So we make sure that we're mirroring your configuration as closely as possible. We can export that in, import that in, from Excel if you've got it there. But all that allows you to do is make sure that you configure in a system asset by asset, because each asset will be different. And that's really, really important. Make sure that each asset is configured to exactly how you want. They'll have different run rates, they'll have different performance rates, and that's really, really important to make sure we're getting the right output figures from an availability point of view and a performance point of view. So make sure that element is nailed down as much as possible. Then in its simplest form, what we look to do then, and this is more for an availability loss, is we'll look at a digital state such as a running signal, and really we're monitoring that real time all the time. And then what we're looking to do then is see when there's a stoppage occur. And then when the machine goes back up and running again, we've then got an event. We've got a period of time to the second on what's occurred. Then what we can simply do then is we provide the reason tree code that we've configured within the system, and this is done on an asset by asset basis. So if I'm an operator on asset 1 on production line 1, then these are the reason codes specific to me. And then the operator just simply picks a reason, and then that's populated in the system and stored. Okay. And then similar, when we look at performance losses, again, we're monitoring the machine. We're getting an output here of an RPM, so maybe we're running a product here, we're expecting 420 units per minute. If that slows down, what we're then looking to do then, again, is capture that loss, but this loss is a time-based loss. So the machine's still running, we're still outputting, but just not at the expected rate that we should be. And then when that rate picks back up again, we'll visually display that to the operator and whoever's got access to the system so they can see that. So again, we've got a secondary event there, that's a performance loss. We've got that information to the second, and then similarly to the availability loss we had before, we'll provide a reason tree code for the operators to use, and then he can give us a reason why they slowed the machine down. And that's just a couple of screenshots we've got here now just to show you how we visualize that to the operator. So as you can see there at the top, we've got the running signals, we've got the downtime events at the bottom, then in the middle of that we've got the slowdown events. So of course what we can do is present that in a list format to the operator. We can capture every single downtime event automatically. They're there, you know, maybe when he gets a bit of a bit more free time during his shift, he can then come along to these if he hasn't already done it and actually annotate these with reasons, because that's really what people want. You know, you want to really understand the real reasons why your machine's slowing down or why your process is stopping. Sometimes it's not possible to get that information right there and then when it happens, but the good thing that we've done is we've captured it to the second anyway. The operator can come back at a later point, maybe he's done a bit of root cause analysis, put the reason code in, and away we go. And that's just an example there of the reason tree pop-up. They just pick which one they want. The start time, the end time's already populated, and away they go. There's some visualization of some KPIs that we can deploy and display as well. So things like availability, utilization, reliability. You can filter that and put any date range in at the top that you wish. The asset hierarchy on the left-hand side, once you click on that, that's dynamic, and that will obviously change to reflect on what level of the organisation you're looking at. So if you're looking at a plant level, it will display KPIs at a plant level. If you're looking at an asset underneath a production line, it will show the KPIs relevant for that asset against that production line. This is more for maybe a supervisor where he's looking at more information across a wider period of time. So again, the great thing is everyone's going to be using the same tool to look at this information. It's all standardised. However, depending on who you are in the organisation, it's depending on what views you're going to set up to give you the information that's relevant to you. And that's an example of some downtime codes there, just over a couple of days, broken down in a bit of a Pareto format. So you can run these reports to show your top 10 losses across shifts, across multiple assets, across lines, across your company, across your organisation. Thank you very much. Any questions? Thank you.